All right, we are going to look at how to identify what ion some element will form on the just based off of where it is on the periodic table. So the first thing we're going to do is we're going to remind ourselves that here in the center of the table, in the exact center of the table, right, is that stair-step line. I want you to remember that that divides the table in half, okay? It's not two perfect halves, but it is two halves. And so on one side we have nonmetals, and on the other side we have metals. All right? And so they form two different kinds of ions. We talked about this one too. Nonmetals, if you remember, tend to gain electrons, and metals tend to lose electrons. And I'm going to talk about nonmetals first because they're the easiest ones for me. To figure out what kind of charge a nonmetal forms is you look at it on the periodic table, all right, and you identify the group. And you find the group number, and you simply take that group number and you subtract 18. And the way I always remember what number to subtract is there are 18 groups. So in this group, you're always going to get a 0 because they don't form ions. Remember, noble gases don't like to react. They don't like to interact with other elements, so they won't form a charge at all. But if I want to look at some other element, for example, oxygen, the oxygen ion that I expect to form, right, is I'm going to take, it's in group 16, so I take 16 minus 18, and I get -2. To fully write that oxygen ion, what I'm going to do is I'm going to take the symbol, and I put the charge in the upper right-hand corner, just like this. So there is the oxygen ion. It's O minus 2. Now, some people are really weird about this, particularly you'll see British people like to write it as O2 minus. I don't know. And some people are even weirder, and instead of putting that, they'll put 2 minus marks up here. I don't know. I don't like that. Both of those as an American confuse me. I prefer to write mine as O minus 2. So you practice right now. See if you can figure out what the chlorine ion is going to look like. You can pause it right now. All right, chlorine is right here in group 17. All right, so 17 minus 18 is -1. When I'm writing my chlorine, by the way, I make my little L like a loop-de-loop L, so nobody thinks it's a C1 or something like that, right? So you'll see me write my chlorine like this all the time. But there it is. There's chlorine ion. It forms chlorine -1. All right, to the other side, we've got metals. Metals tend to lose electrons, all right? So what we have with them is there are two different kinds of metals. There are the S-block metals, all right? And then there's every other metal. And technically, this isn't every other metal. We're going to talk a little bit about how some other elements get mixed in there, like metalloids, sometimes even non-metals. Ooh, even the noble gases? What? That's crazy. But for now, we'll just break this down to S block. So remember, S block is group 1 and group 2. Right? Remind yourself that's the S block right there, group 1 and group 2. Group 1 elements always form +1 ions every single time. And you'll never guess what group 2 ions are. Group 2 ions are always +2. You got it. So, for example, if I'm looking for sodium, sodium's right here in group 1. Sodium is going to be, let me put out here sodium. Sodium is Na+1. Group 2, something like magnesium, for example, the way magnesium forms an ion, it always forms a +2 because it's in group 2. Easy enough. Everything else you cannot determine by the periodic table of the elements. Everything else on the periodic table you cannot tell. You would have to be told what the charge is. And we're going to talk here in a little bit, maybe during class, what tells you the charge. I give you a hint. If you remember your Roman numerals, you're going to know what the charge of manganese V is. If you don't remember your Roman numerals, you're in for a treat.